and we are.
Okay, is that on YouTube?
So
Right?
we're live now. We're live. Yeah, that's YouTube. We're live. Let me double
Okay, great.
check. Let me double
Great.
check because as we wait for some people to show up, I just wanna. I will just check quickly if the voice is getting through correctly. Because last time we had
Mhm.
we had an issue, and I want to make sure
Okay,
that
so right now you are on Twitter or
I'll share
YouTube.
YouTube. So we're live on YouTube. But I will share the link
Okay,
in. I'll
I'm
share the
hearing
link
you
in
too.
Twitter. I'll share the link in Twitter. Um,
Hmm.
so let me see. This needs
Yeah,
to.
I can see myself on Twitter right now.
You can see yourself.
Yeah, on Twitter right now. Yeah.
Okay. Qubits Off with Kareem. I'm gonna see if I can hear your voice. That's the most important thing.
Okay, I hope so. I hope
Yeah,
so.
yeah. Yeah. I can hear your. I can hear your audio. That's cool. That's awesome. So let me just share the link in Twitter quickly. Join us with Kareem. Do you have a Twitter handle? I think you do, right?
Yes, yeah, yeah. I'll
I
send it to you
do.
right now.
Do I?
Okay. Here's my. I sent it in the
Oh,
chat.
Kara
That
QML.
is
Okay,
my.
cool. Let me
Yeah.
see. So with Karo QML. Sorry, it's going some my browsers, but that's good. No, so join us with Kara QML in this live episode of Turn. Oh, I'm slow. The Qubits Off. That's good. Cool. So I'm gonna tweet these, and I will just go ahead and then see. Okay, so we got the. I'm gonna share with you the link now, and the link to the puzzle. Okay, and so what I want you to do is, I want you to basically share your screen, right? I think that's gonna be the best way. So I
Okay.
shared the link, and then you can click on the link and share your screen.
Okay. Is that okay?
It's coming up. Yeah, that looks good. Okay, cool. So maybe first let me explain you. Okay, so what's the goal with this puzzle? So the goal with this puzzle is to turn the three qubits at the top to zero, but
Mm-hmm.
but you have the following constraint: you can only add gates to the bottom two qubits. So it's as you can see, it's there's a mystery gate that is controlled by an input. This is something that
So
it's a
let me get this straight. I'm sorry to interrupt you. So
no problem.
here in the last two qubits, I cannot modify,
No,
right?
no, you can. It's the only ones you can modify. So you can put
So
gate. You can
only these two, only
yeah
these two.
yes you can put gates both before the input block or after the input block. So you can put in both in front of or afterwards, but you cannot touch the top three. And other than that, you can
Okay.
feel free to drag and drop the gates. Feel free to do whatever else you want, but not don't place gates on the top. I mean, you can if you want to place gates in the top one to try to understand something about the box. It's also okay.
Yes, that
But
would be great.
the final solution should only contain qubits at the gates at at the two qubits that are at the bottom of the circuit. Does that make that?
Yeah.
It's fine. Don't worry. I mean, if you do something that's illegal, I'll let you know.
Okay. Okay.
And if you can walk us through your process, then your mental process as you do that,
Mhm.
it's you know, it's even better.
Okay. So right now we have here 50 and 50 and 00032. Is that like a Hadamard? Just a second. Oh, okay. So no Hadamars here. What about now? So everything is on. Can I just like do something like a
Yeah,
post?
exactly. Just use, you can use whatever gates you want, so you can try to
Uh-huh.
understand what is going on. But then, the post selection gates cannot be part of your solution, but they can be used
Sure,
to help you understand the stuff. Yeah.
sure. Okay. So if I put one here, so everything is on. Okay, I think that there is like I well starting from here, I think that there is some C not connection here or an interaction between the last two qubits. Let me, so if this is off, nothing changes here. Okay, what about one? So no, so the controlling qubit would be the last one, and it would control this one. Okay, yeah, so let me do this. What about now? Nothing happens. Okay, what about now we're talking. Okay. Um,
So what's your current strategy? Maybe like what are you trying to achieve?
well, I'm trying to to make this one off, and I'm trying to understand how to make this off.
Remember that the ones you have to turn off are the other three.
Yes, yes,
Okay.
the first three, but I want to understand the connection
Okay.
between the last two qubits.
Okay.
I
Okay.
mean, there's something there must be something between the last two qubits here. Uh, so the x crossover here, and okay, what about and an h? Nothing happens. This is weird. Okay. Also, everything is on.
I'll share the puzzle in the chat if there's anyone that's watching that they want to try it by themselves. They're also welcome to do so.
I think I'm getting a bit close here. I think so. Okay. Okay.
Okay, you solved it. Okay, cool. Yeah.
Well, actually, you told me that I should not make these two qubits like
you,
to be turned off, right?
you don't have to. No, 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 no. Look, you solved it. You don't like. My point is, you don't have to. But like,
Okay.
it's actually. I think if I recall well, the way I designed the puzzle, that's the only possible. That's the only possible solution. I think. Yeah, because you. Mhm.
I'm trying to find the connection between the last two qubits.
There's
There must be some connection, right?
there's no connection between the last two qubits. So let me you can do the following. So do you see
Really?
can you hear
Just a
me?
second. I think. Yeah.
Yeah.
Yeah. Now.
So do you go to the URL?
Which URL?
Do you see
Which
the URL of the browser
this one?
of your browser? I don't know. You're sharing a browser window or something.
I'm only sharing the tab that you sent me,
Yeah, yeah,
or
exactly. But like if you take a look at the URL of the puzzle, right?
just a second. Let me share my whole screen right now. I think that would be better. Okay.
So
So
so there's if you wanna, this is like a trick for those who want to understand, maybe open up the box and see what's behind, right? So if you click on the URL and go to the very end,
mhm.
at some point there should be a parameter called dojo.
um, I don't see it.
You skipped it. So you see there's show output superposition. Like if you go back, sorry, not to the very end, but like move to the left until you see something called dojo.
Yeah.
So
Enable.
turn this to false. So type in enabled false. So that basically disables the puzzle mode, and then refresh the page.
Okay.
So now you see the initial states, right? And then if you
Mm,
hover over the little gloves gate at the bottom left, at the bottom right, sorry, at the bottom right of the toolbox, in the toolbox, down, here you see the content of the secret gate. So basically, ba-
Uh-huh.
basically, like, look at this. Basically, this is a bunch of it's a bunch of parameterized
Yeah.
rotations, right? So
It is
the it's
Z to the power of A over 2, right?
exactly.
Yeah.
So it's a
Uh-huh.
z is a z rotation, a y rotation, and an x rotation, and the only way that those rotations kind of turn, like, stay at, having no action at all, is when the input is 0. Um,
Mm-hmm.
and so you had a really good intuition here, because you wanted to understand more about the input, and so when you turn it off, it, by chance, it turned the rest off.
Mm-hmm.
So it's I very much like the way that you approached it. Yeah, it's an interesting, an interesting idea. But yeah, cool. I mean, that
Thank
was
you.
quick, but that's the idea, right? So there was no
Yeah.
connection between the two qubits. I guess what you were seeing here is because the way that this is implemented, I guess, and within Quirk, is, I mean, you're like, the qubits are all entangled with each other, I guess, essentially,
Yeah.
because you're putting an input gate in there. I haven't myself dived too much into how this input is implemented in the tool, but it's definitely using, it's an
I
entanglement.
think there should be like a C note or something between these two qubits here. I think so.
Could be, yeah, exactly.
Yeah.
So I think the way this is implemented maybe creates the
There
entanglement
must
that
be
you were
some.
seeing.
I think the interaction would be like a controlled rotation, but perhaps a controlled rotation, but with like some complicated gate here.
Yeah,
For
yeah.
example, like the T gate or the Y gate. I think. But anyway,
Yeah, I mean, it was.
I'm glad that I solved it.
Yeah,
Okay.
exactly. It's thanks for agreeing to do this live. Maybe you can use some time to talk a bit about yourself and what you do, and because we
Oh,
haven't we
okay.
haven't really done this in the beginning.
Oh, okay. It's okay. So, first of all, my name is Kareem Softi. I'm an Egyptian. My educational background is based on communications and electronics engineering. I right now I am an AI engineer, so I made like some career shift here from communications to the computer science field.
Uh-huh.
Uh, my main focus is computer vision and optimization problems. I also work as a quantum machine learning researcher at Wigner Research Center for Physics, and I'm also a research member in Alexandria Quantum Computing Group in Egypt. And the Wigner Institute is in Hungary. Uh, I'm also a Qiskit advocate, and
Oh, cool. Okay.
yeah, yeah. And currently, we are or we actually have a live round
I lost your voice.
can you hear
So
me now?
yeah, now, yeah.
Okay, so right now we have a live round for the Qiskit Advocate Test exam, and anyone can actually jump in and apply for it. But the most important thing that you should be at least active, or like active in the community of quantum computing in general and Qiskit especially. Uh, uh, I don't know what should I say next,
Yeah, no,
but
it's cool. I mean,
yeah.
it looks like you're a really busy person. I mean, you're involved in many, many things. I was
Yeah.
just curious how you got into quantum computing in the first place.
Well, I wanted to do physics the first. I didn't like engineering that much, but not everything I like that goes the way I want. Anyway, so I started to learn physics on my own from like basically from university up until I graduated. I followed the MIT courseware, open courseware website. They have like tremendous courses there. The most important ones are the 8.04, 8.05, and 8.06. They are about quantum computing. And then after having like a good basics in or how can I say this, like a solid background in quantum physics, then I started to move to quantum computing to merge the two fields that I'm actually studying, the physics and engineering.
Okay.
So I first of all I found the quantum mechanics and quantum computation by Professor Omish Vajrani on edX platform.
Mm-hmm.
It's an amazing course, and it gave me like a good intuition behind what is quantum computing in general. And after that, I took like around 5 courses on edX from Quantum Information Science series on edX. They were actually a bit tough, and they gave me actually some hard time to grasp the concepts and everything. They were like graduate based courses, but they were actually amazing. So
Okay.
I do recommend everyone to
You recommend that?
Yes, on edX.
Yeah.
Uh,
Nice.
Actually, there are also like two important textbooks that I do recommend. Of course, the first one is Mike and Ike, the Quantum Computation.
Yeah.
I don't remember the full name. There's another one which is called Quantum Computing Explained by David McMahon. It contains a lot of solved examples, and that made my life easier a lot, like
Okay.
literally a lot. So it's an amazing textbook. Finally, I started to specialize more and more in quantum machine learning because I do AI or machine learning in general. So I thought that merging the two fields will be beneficial for me in the academia and also in my industrial career. And
That's
the first
a
thing that, yeah.
that's a nice thing. One of the things that I want to do is I want to be able at some point to create puzzles that are a bit more vertical specific, and I'm thinking about like creating some kind of puzzles that are like a bit more in the within the QML area. And yeah, I think that's something that I'll definitely we can do sort of another run on different puzzles later on if you'd like
Yes,
in
sure,
some of
sure.
those topics. Yeah.
Sure. Good thing, yeah.
Yeah, cool. Yeah, I mean that's it. To be honest, it was fun. Thanks for sharing your a bit of your background and the references. If
Mhm.
you send me the references of the books, then I'll put them in the show notes later on, so people can also click on the
Yeah,
books,
yeah,
and
yeah, sure, sure.
that makes a lot of sense.
That would be great. Just give me. I can send it now. Just a second.
Yeah, I just put them now.
Just a second. Okay. Um, these are. By the way, I shared these resources in the Cascade Summer School or Cascade Global Summer School
Okay.
that is currently going right now or live right now.
Yeah.
I send it here. Okay, in the chat.
Okay. Perfect.
If you opened it right now, you would see like it is more oriented towards quantum machine learning, but at the beginning you will find some useful resources for machine learning refreshment. But I built this list like if you should at least have some machine learning background. Okay, that is the first thing, and then here in number two you would see some important introduction to linear algebra, which is like
Yeah,
a
that's cool.
really crucial thing in quantum computing, and then some introduction to quantum computing, of course, the Qiskit textbook and the course that I told you about,
Yeah.
the quantum mechanics and quantum computation. And also that if someone actually wants to learn some quantum machine learning from like amazing person, unfortunately he's gone right now, so may God rest his soul, Professor Peter Wittig.
Yeah.
After this, there is this great tutorial using Qiskit and PyTorch for quantum machine learning. This is by Amira Abbas. She is also a Qiskit advocate, and she's doing a wonderful job. Also, of of course, the famous Penny Lane framework for quantum machine learning. Here you can find it in
Cool.
where is it? Yes, in 8. I've also included some of my notebooks here in 6, as you can see. Okay, and lastly, you can see here in 9 that there is this new field, or you can say that new direction, which is quantum natural language processing. These are some important talks and some papers, a Medium blog post.
Cool.
And that's it. And finally, you would see some great online sessions about quantum machine learning in general from different actually wonderful guys and women.
That's cool, man. That's it's a lot of resources.
Yeah, you can show them.
Yeah, basically, I shared them in the chat, and I'll put them also in the show notes. There's there's someone in the chat who's asking whether they can take your email address.
Okay.
I guess if they want to connect, I don't know who this person is, but feel free to write either to me directly, and then I'll get you guys in touch. Maybe if you don't want to share,
I will give you my LinkedIn. This is like the best place to communicate.
To connect. Okay, then share your LinkedIn here. Cool. I'll copy it in the. I'll copy it in the links, and so if people want to get in touch, here you go. And I'm gonna, I think we can leave it here. Thanks a lot for your time. It was fun. You solved the puzzle super quickly, and I'm happy.
Okay.
Yeah, but that's good. I'm happy. My goal with this series is to expose people's way of thinking, like in a snappy kind of raw way, right? Like I don't want people to prepare a lot for these and think too much. And I think jump right into this, and if you got it right from the very beginning, and it's cool, man. It's really cool. I'll publish this puzzle and the other ones in my webpage as well. And yeah, stay tuned for more videos this week. Yeah.
Okay.
Then live stream is ending now. And done. Cool.
Okay. By the way,